This is example problem 9. So 9, 10, and 11 are a little bit easier problems, but they're problems where you're solving for an unknown. So we're not just adding vectors like we did for example problems 1 through 4. It's kind of you're drawing vectors and writing equations based on the vectors to solve for something. But they're not super hard. But I'm just showing these to show you, to expose you to kinds of problems. So for this particular problem, you're given a b vector, which is 900 newtons at 30 degrees below the x-axis. And you want to find an f vector of magnitude at theta such that b plus f is equal to a resultant vector that's equal to 1200 newtons along the x-axis. So to draw a picture of what the problem is asking, some f at theta plus a b at minus 30, those guys should add to an fr vector, which is equal to 1200, that acts along the x-axis. So this is the picture of what we're trying to solve. And I can't overemphasize to you that being able to sketch this picture is a great way for you to be sure that you understand the problem and let the picture guide you as you're writing a solution. So you could solve this triangle using law of cosines. So if you've got a side length here, and one angle, you can use the law of cosines to get f. And once you get f, you can use the law of sines to get theta and everything else. So you could do it that way. And I trust if you're looking for a good time, you could try it. But we're gonna write equations to solve it. So in the x direction, we have f cosine theta plus 900 cosine 30 is equal to 1200, which gives us equation 1. Equation 2, we've got f sine theta minus b sine 30 is equal to 0. So my equation 2 is f sine theta is equal to 450. If you divide equation 2 by equation 1, we have f sine theta divided by f cosine theta. The f's cancel. You're left with tangent of theta is equal to 450 divided by 420.6. So my theta is 46.9 and my f is 615.9. And so this is not an unusual problem in a statics textbook. Equation 10 is similar. Example problem 10 is similar. So I have a b vector, which is 300 pounds at 40 degrees from the negative x. I have an f at theta. And so I want to determine the f and the theta such that f plus v is equal to a vector that lies along the y-axis, and it's 600 pounds. So the picture is f at theta plus b, which is 300 at 40 degrees. This guy plus this guy is equal to fr, which is 600 pounds, acting in the positive y direction. Again, you can use the law of sines or law of cosines to find f, and then law of sines to solve this triangle. But we'll just write x and y equations. So based on this picture, in the x direction, I have f cosine theta minus 300 cosine 40 is equal to 0. In the vertical direction, I have f sine theta plus 300 sine 40 is equal to 600. And that gives me an equation 1 and equation 2. I divide equation 1 into 2. The f's cancel. I get tangent of theta is equal to 407.2 divided by 229.8. and I get F, which is, I get theta, which is the inverse tangent of this guy, which is 60.6 degrees. And then plug this into one of these equations and get F is 467.5 pounds. Two similar problems. Again, you're just formulating the problem, coming up with a plan of attack, and then executing it. And again, you could do it graphically, or you can write X and Y equations. You should be able to do both.